Hi, in this video, we will talk about how we can optimize mobile user acquisition budgets efficiently by making an econometric model in Google Spreadsheets. As you know, measurement and tracking is a mess after iOS 14 and app tracking transparency. As we looked for solutions to the tracking issues that we faced on our team at Rocketship HQ, we found econometric models to be hugely impactful in the absence of deterministic data. The best part? You can get started with just a spreadsheet based model without having to write complex code. And I will share with you how we do it with an actual spreadsheet walkthrough. Here is a brief intro about me. I'm Virendra Shekhawat, Senior Performance Marketing Manager with Rocketship HQ. I have over 6 years of experience in mobile marketing and a deep interest in analytics, and having led a number of analytics initiatives at Rocketship HQ. I'm also currently doing an advanced course on big data, machine learning, and advanced statistical analysis from Indian School of Business, India. Right. To start with, let's first see what do we mean by forecast. So the forecast is a process of predicting future sales or any other KPIs that we have like trials, revenue, etc. And this we will do with the use of historical metrics, the data that we already have, which in our example here is the spending from all the paid channels and then previous sales we had. So the next question which comes is why do we need to do a forecast and how will it help us? As I mentioned earlier, tracking is pretty much broken on iOS after ATT. Scan numbers often don't make sense. Google reports based on Firebase, Facebook based on scan, and ad networks based on probabilistic metrics, and it's impossible to find out which source is performing better than others. As a result, we need a robust solution so that we can optimize budget allocation and maximize our online sales. With a forecast, we have the ability to answer questions like: is Facebook really responsible for as many sales as they are reporting? Or did a new channel actually drive the spike in sales? Or was it some other factor like holidays, seasonality, etc.? Or maybe since we improved the user flow, it improved the conversion percent. An additional question can be: what would happen to revenue if I increase my marketing budget on specific channels? How much data or an increase it will bring to our future revenue? So, these are some of the questions that we will try to answer through the forecast model. Now, let's look at the ways we aim to do forecast here. There are multiple ways through which we can do that, but here we focus on two methods. The first one being Facebook Robin, which is an automated marketing mix modeling code that runs on RStudio. And the second is what we would be discussing in detail is the econometric model, which is an spreadsheet based model. We will talk about Robin in a subsequent video, but for now, we will focus on an economic model in Google Spreadsheets. So, now the first thing is what is econometrics, right? So, econometrics is applying statistical techniques to economic data. These techniques were originally used to predict macroeconomic data like GDPs, interest rates, etc., for countries and states, and these have been adapted to predicting marketing outcomes. In other words, we will be applying statistical techniques in order to identify the relationship between the input data and output data. In terms of application, we will be trying to predict sales, trials, or subscriptions based on factors like how much we spent on advertising across channels. And these factors we would input as variables. Post that, we would be doing a multilinear, multivariate linear regression analysis. And we will have coefficients as the output that we will be plugging in to form an equation. In terms of methodology, we will require known data by variable that we want to predict, which in this case is purchases. But we can have some other conversion metrics as well. Also, we will be taking known data, which is x variables, that we believe would have an impact on the y output variable. So, for example, in this case, we will be starting by taking spending only from multiple channels, but we can take impressions as well along with this to make our model more accurate. The next step would be to use Linest function, which is a least squares method to calculate a straight line that best fits our data for forecasting. And over here, we see that this is the function wherein we will have known data y, the output that we want to predict using known data x, which is spent for various channels. Calculate underscore b is an optional variable to calculate if we need the intercept, and verbose if we want some more statistical functions along with the basic coefficients. By default, calculate underscore b is set to true, so we can have intercept, and verbose, which by default is set to false. I suggest taking it as true. Here I have used verbose function set as false and true both. Moving forward, so the number one step that we need to do here is inputs, right? So as you can see in the screenshot here, we have y, which is the known data that we would like to forecast. In this case, it's sales. And then the x data from x1 to x5, which is the known data that we have, the spending from multiple channels. X1 to X5 can be channels and can be anything from Facebook, Google, Liftoff, ASA, TikTok, or any other channels you are spending on. As we can see, we are taking week on week metrics here for last 15 weeks. But I suggest to take it a larger data set as possible. I have taken last 15 weeks here to make the model easier to understand. More data will allow the model to accurately predict and forecast. As next steps, we will apply Linest function. As we see over here, y is the output variable that we want to predict. X are input variables, which is D3 to H17, which is spent from various channels. Calculate underscore b is set to 1, as we want to have intercept, and verbose set to 0, which by default is a false function. So we won't have any other additional statistical values over here. We see that here very nicely it gave us coefficients for each media, but please note that we get these in the reverse order. Based on this, we can easily create a line using these coefficients and intercept and forecast purchases. Now let's change verbose, which by default was set false to true. So instead of 0, we will have made it as 1. And now as we see, there are multiple stat values that we are seeing in all statistics column. But what do they mean? If we go to the descriptions that I've added for simplicity, we can see that all these values imply. For example, the top row that we are seeing over here is a coefficients value. We also see R square value here. As we know, R square value ranges from 0 to 1, and R square of 1 means that all movements of a dependent variable, which in this case is purchases, is completely explained by the movements in the independent variables, which in our case is spending across paid channels. We also have coefficients and intercepts here as earlier that can be used to form a forecast equation. We see purchases here that we want to forecast, and then this is our equation, which is coming from the coefficients. So 0.05862 multiply channel 1 spend plus 0.2081 multiply channel 2 spend, and so on up to channel 5, and then we add our intercept. We have here an equation that can forecast purchases. Here we also see contribution table, which tells us how many contribution each individual channel is bringing to the total purchases. So we see over here the channel 2 and channel 3 are maximum contributing to our overall purchases. So what does that mean? That means that our most important channels that we may want to increase the spend on. Channel 4 here is negative, so it's not making any positive or negative impact on the purchases. So either we need to shut it down or should give it some more time. Or maybe we need to decrease the budget. Now, based on the equation, we can also create multiple scenarios. For example, over here, we see that if we increase channel 1 budget by 2x or 4x, what do we see? So when we do that, we see that our CPA purchases have increased to $14 or $16 approximately. Similarly, we can devise multiple scenarios here where we are spending more, or maybe channel 2 or channel 3, right? In another example, we also see that if we increase the channel 5 budget by 4x, our CPA, that is cost per action, is the best, roughly $7. So that means in order to be most efficient, we have to increase the budget on channel 5 so that our CPA is the lowest. In nutshell, this forecasting has given us a glimpse of budget allocation in a way that on which channel we want to increase our spend on in order to get the maximum return on action or lower CPA. However, before taking any action, we also want to understand if the model is even accurate. So to do that, we see R square value, which tells us if the model is strong or not. Here we see that R square value is 0.92, which states that model is able to explain movements of a dependent variable, that is purchases, by movements in the independent variables, that is spend across channels. We also see error percent here in the chart, which is plus minus roughly 10%, meaning we can expect 10% error in our forecasted values, both sides. That is, they can be under or over than real values, real purchases we may get in real life scenario. Now, whatever we have seen on the slides, let's do that over a spreadsheet as well. Please note that we will be sharing this spreadsheet along with the slides in description. As we saw, here is our spend for all the channels. This is our output that we want to forecast. We apply Linest function over here. First with Verbose is set to false and then set to true. We get all the statistical numbers here and the descriptions are placed in the bottom down table. We see that 0.927 is our R squared value. Also, we devised an equation using these coefficients of these channels. We have here forecast values using the equation and then the contribution from multiple channels. We also see some graphs which are fairly intuitive to understand. In the graph here, we see that our purchase forecast line is quite in sync with the actual purchase line. We also see a lot of other statistical values that we may want to look in detail, but here we want to be focusing on the error percent. We see that error percentage is less than 10% both sides, positive and negative. Then we do a forecasting wherein we have taken all these coefficients and multiplying them with the respective spend of all channels. And then add intercept value at the end. We also see here the multiple scenarios which we just went through. That is, if we increase channel 1 spend or channel 2 spend, what we can expect here. So to sum up, this model has told us how to predict the future purchases through a forecasting method. In here, we are using a Linest function, but please feel free to explore some other functions as well that you may find and drop a note in comments. In our subsequent videos, we will go a few steps further and will discuss automated media mix modeling by Facebook Robin. Facebook Robin can automate this entire process and will require coding expertise on RStudio. If you would like to have us help you build an econometric model for your product using this method or with Robin, or if you would like to explore our services for user acquisition or creative production, please go over to rocketshiphq.com or send us a note at hi@rocketshiphq.com. So for today, this is all that I had. Thank you.